Okay, for this series of questions that we're going to follow, we're actually going to use the formula z equals the data value minus the mean divided by the standard deviation. They will give us the mean and the standard deviation, and the x value. We'll do this calculation. We'll get our z-score. So, starting off with question 22 here, we have x is normally distributed, that's important, with a mean of -1 and a standard deviation of 2. What is the z-score of x equals 2? So notice, we take this formula, the x goes first, so the x is 2. We put in the mean, we're going to subtract the mean, so we're going to subtract -1, and then we're going to divide by that standard deviation, which they tell us is 2. So subtracting a -1 is the same thing as adding 1, so this becomes 2 plus 1, which is 3 over 2. It's a positive value. 3 divided by 2 is 1.5. That is our z-score. Let's take a look at another, 23 here. So suppose it's approximately normally distributed. So we're going to approximately use these formulas. We either use them or we don't. We can't halfway use them. So we've got a mean of 12, a standard deviation of 6. And we're looking for the z-score of a score of 2. So we put the x value in first, which is 2. We subtract off the mean, which is 12, and we divide by the standard deviation of 6. Now be careful, if you're using a calculator, if you enter it just like this, 2 minus 12 divided by 6, you won't get the right answer, because the 6 will divide into the 12, and you'll get a wrong answer. So if you're going to put this in a calculator all at once, you're probably going to want to put some parentheses around it to make it all work. 2 minus 12 is -10 divided by 6, or you might do it this way. -10 divided by 6 is going to give us the number -1.666, so we'll round it to 67. And that's our z-score. 24, let's just keep going. We have a mean of 9, a standard deviation of 3, and we want the z-score for an x value, a data value of 9, a measurement of 9. Now this, I agree, is all abstract, but you could put anything into these measurements that you want. So we're looking for an x-score of 9. We subtract off the mean, which is 9, and we divide by the standard deviation, which is 3. 9 minus 9 is 0, divided by 3, which is 0. So notice when our data value is the mean, the z-score becomes 0. You see how when we start working with this, it all starts to make more sense. For 25, what we have is we have a mean of 6 and a standard deviation of 1.5. So we're going z, and we want to know the z-score for some data value that is 5.5. So the data value goes first. We subtract off the mean, which they wrote out in letters, so that sometimes throws us off. And then we divide by the standard deviation of 1.5. We'll do the top first. 5.5 minus 6 gives us a -0.5 in the top, 1.5 in the bottom. Do the division, and we get -0.33 repeating forever, and that's our z-score. In the next series, we will start taking a look at how to use these z-scores to find percentages. But let's continue on here a little bit. We've got all this to go. So 26 and 27 are going to be similar type questions. So 26 first, we've got a normal distribution, x equals 5, and the z is -1.25. We don't know what the mean is, but it doesn't matter. It tells us that x equals 5 is how many standard deviations. It's 1.25 because a z-score is standard deviations. And is it going to be to the left or the right? Well, since it's negative, we know we are to the left of the mean. Okay. 27, and maybe a little visual mean negative 1.25 is over here, it is to the left. 27, we've got a data value of 3, and we're told that it has a z-score of 0.67. So again, it tells us that the standard deviations from the mean, that x equals 3, is exactly 0.67 standard deviations away from the mean. And since it's positive, it tells us that x equals 3 is to the right of the mean. And 28, we have x equals negative 2, z equals 6. Wow, 6, that's a big one. So it tells you that x equals negative 2 is how many standard deviations? 6. And since 6 is positive, it is to the right of the mean. Now, 6 is way out there. Remember, 3, we got to 3, we're like at 99.7 in both directions. So 6 is, this would definitely be what's called an outlier if it existed. So z tells us how many standard deviations away from the mean, and a positive in these two cases tells us that it's to the right. A negative tells us it's to the left.